In this video, we're going to talk about how we can measure intervals. We know an interval is the ratio of the frequencies of two notes, but how can we measure it? The only interval we know how to measure so far is the octave, where one frequency is twice that of the other. To measure other intervals more precisely, we use things called cents. The cent is a logarithmic unit of measurement, and we use it for intervals. By definition, the 2-to-1 ratio of the octave is defined to be 1200 cents. So we have 1200 cents in an octave. Because cents are a logarithmic scale, whenever we're going to add intervals together in cents, we can actually just add the numbers of cents, because that will correspond with multiplying frequency ratios. How do we convert a frequency ratio into a number of cents? Well, it's a simple log formula. We use the log to the base 2, frequency of 1, frequency of 2, and we multiply that by 1200. This works because log base 2 of frequency 1 and 2 are the same, so frequency 1 and 2 being the same, that will be 0, and the interval will be 0. When they are one octave apart, it will be 1. So then we will have 1200. To convert an interval into cents, we need to get the log base 2 of the ratio of the two frequencies and multiply that by 1200. So if we had a 300 Hertz tone and a 200 Hertz tone, the interval in cents would be 1200 times the log to the base 2, 300 divided by 200, which would give us 701.995 cents, which is a perfect fifth. Sometimes we just want to know what the number of cents are between a particular frequency ratio. So we can just put in that frequency ratio, make it to the log base 2, multiplied by 1200. So if we just had a question like what number of cents would be a frequency ratio with 3 to 2, it would be 1200 times log base 2 of 1.5, which is also 701.995 cents. The only problem is we don't have easily available log base 2 on our calculators. We could convert it, but that's hard. The easy thing is we get our frequency ratio, we get the log base 10 of it, and we multiply that by 3986. Now, the 3986 comes from the fact that we want the 1200 cents and we're converting from log base 2 to log base 10, and those of you who understand logarithms will know what I mean. If you don't, it doesn't matter. You just use 3986 times log to the 10 of the frequency ratio. This is an example of some frequency ratios turned into cents. Now we can also convert it back the other way. So the note frequency is the base frequency times 2 to the power of x over 1200. So if we had an interval of 400 cents and a base frequency of middle C, which is 261.6, we would multiply it out and get 329.6 Hertz. Because calculators have already a 10 to the power function, we can use 3986 instead, and it works exactly the same way. So when you're doing it, this is the formula to use. For practice, work out these with your calculator.